Thank you for joining the Once Changing the World, which is India's first future tech meets sustainability podcast. And today, I'm delighted and honored to have with me Mr. Kevin Warwick, who is an engineer and Deputy Vice-Chancellor at Coventry University. He's known for his studies on direct interfaces between computer systems and the human nervous systems, has done research in robotics, and is the author of various books such as The Quest for Intelligence, Cyborg, March of the Machines, The Breakthrough in Artificial Intelligence, the Basics, and Turing's Imitation Game. So Kevin, really appreciate you taking time and being part of our Humble podcast. You've been known as Captain Cyborg, one of the world's first human to become a cyborg. So maybe talk to us about that, that was way too early. The entire ecosystem has evolved. Right now we have companies such as Neuralink and Kernel and others who are the cutting edge of wearables. So maybe talk about the challenges of being the first cyborg and what's the current tech stack at this point in time if somebody wants to do an implant.
Yeah, well, all the experiments that I did in myself and with students that were with me, we had medical, so doctors carried out the procedures. So part of the issue I think nowadays is who's going to carry out the procedure, and it needs, for safety's sake, it needs a doctor. I think some of the people that call themselves biohackers take considerable risks if they try and do things themselves, even putting something under the skin, the possibilities of infection, or you haven't sterilized the whatever it is you're implanting. For me, though, I was involved with doctors all the time as part of a team, I guess, to put things together. The implant that I had, which was in 2002, so that's quite a few years ago now, it was called the Braingate. It was 100 electrodes, and that was fired into the nervous system in my left arm. And what the more medical people in the team wanted to do was to look at things like, could we stop pain by an implant? Could we put electrical signals into the body that would help, rather than use an aspirin for chemicals, things like that? Could we do it electrically instead? So those sort of things, which were rather like the deep brain stimulation you get for Parkinson disease. In fact, one of the surgeons, that was his main role. But I was looking with an implant in the nervous system at twofold. One, could we pick up signals from my brain that were going down my nervous system to move my hand, as they're doing now, take those signals, plug them into the internet, connect something else to the internet, so my same signals, neural signals, would then control whatever it was. One thing we did was a robot hand. Didn't have to be a hand at all. It could have been a building or anything, but it was a hand, perhaps to show people what was possible. And in fact, what I did was to control a robot hand. I was in United States, in Columbia University, and the robot hand was in England, in Reading University. And I was able not only just for my neural signals to move the robot hand, but the fingertips of the robot hand had sensors on it, and signals were sent back to my nervous system to stimulate my nervous system. The more the hand gripped an object, so the more signals on my nervous system that my brain was getting. So I could feel how much force the robot hand was applying on a different continent. So it was like extending my nervous system across the internet. That was one part of the experiment, which could obviously help somebody when it comes to if they're paralyzed in some way, but their brain is still functioning, or they've got a break in the nervous system and paralyzed in that way. So you could look to jump the signals over the break and help them potentially in the future, help them get back to walking again or moving hands. So it was looking partly for therapy for the doctors involved with the project, and partly for me, just purely, can you have a person in one country or one planet, for example, who is controlling something that is them, is their body, but it's on a different planet or different country. That was one part of the experiment, which I don't think science fiction, I don't feel, has actually got there yet. I mean, Iron Man couldn't do anything like that. He couldn't, with his brain, control something. I don't think so anyway. Maybe I'm wrong.
It's quite pioneering. You mentioned about, today's biohackers experimenting with different techs and implants and wearables to augment or enhance them. So you were one of the earlier pioneer of, one of those biohackers, who kind of created an implant called Braingate, 100 electrodes, left arm. And you mentioned that it had also sensations where you could touch, feel things,
Yeah. Well, I think just doing the implant is something that you tend to gloss over or forget about. But when you're the first one, and the Braingate, that array, I mean, the Utah array, which was where it originated, to my knowledge, had not been put in a human before it was put into my nervous system. So the surgeons that did that, these were consultant neurosurgeons at John Radcliffe Hospital in Oxford, for example, which was where the operation took place. So for them, it was a research project as well. How do we put this into into somebody's nervous system? How do we fire it in? How does we get it to stay there? What's going to happen to it in over a period of time? And I mean, they were quite restrictive. I was duty bound to stay silent for about 10 days after the operation for them to make sure that there were no adverse effects, that it was going right as far as they were concerned, before I could tell anybody, yes, this is what happened, in case there was some problem that needed to be looked at from a medical point of view. So for the surgeons, it was a research project. And one or two of the papers that we published subsequently jointly were more in medical type of journals, which was not really my background until being involved in the project practically.
2002, early days of tinkering around with something which is so futuristic. We've seen this in books, we've seen this in movies, and now it's becoming a little bit more practical. These electrodes numbers are growing, and it can do many things. It can read and write a larger area of any part of the human body, whether it's the brain or like you said, it kind of put it on a left arm. Talk to us about not just the pros and also the cons. I mean, do you still have it? It's removed. What was the learnings, and how has that learnings or understanding being leveraged for possibly products or application you spoke about, which could really impact the healthcare industry?
Well, I think there is some limited use of the same material, the same implant, to make connections in the brain for people who are paralyzed, to help them move technology and so on, so that they can still think about moving, even if those movements don't result in physical movement of their body. But those things in the brain, the signals can be picked up and sent out to a robot hand, and someone can feed themselves. But in a way, it's still research ongoing, and it is more therapeutic. It is more helping people who have a problem of one kind or another. To some extent, I've been disappointed that there haven't been more experiments of the same kind, but along those lines. Elon Musk has talked for Neuralink, has talked about what we are going to do, and obviously I look at it and I have technical questions as one would, but it's very encouraging that someone is at least talking of doing such experimentation. It's surprising that there hasn't been more, because in a way, from a scientific point of view, I want such experimentation so that then someone can say, well, Kevin Worry, he got this right and did that well, but this he should have done it in a better way. And then I get my papers researched and referenced and things like, that's how the academic world works. But for non-therapeutic use, which mine was not for therapy, although the surgeons involved were looking more at that, I was looking at the enhancement side of how can you take a regular person and improve their capabilities or change the capabilities, give them extra senses. One thing I did was have an ultrasonic sense, like a bat sense, which was great. I mean, it was great fun being able to detect objects without looking at them and so on. But that could be useful for someone who's blind, but it could be that everybody could have such a thing. And it's a shame that I haven't seen anybody do similar experiments or experiments along those lines where they could look at increasing the range of senses to people to have ultraviolet and X-ray, all sorts of different sensory input. But it's not happened yet, which I'm surprised at.
I mean, there are just few brave people who kind of go against the society, because I mean, it's not just about building technologies. It's about the moral and ethical system around which you need to kind of answer to, and so that's the reason I think, I mean, things have not like really progressed. But yes, there are many companies around the world who are now tinkering around and asking brave questions and are going beyond. Can we add an extra sense? Because I'm sure 20 years back, I mean, even that question of can we add an extra sense was something which would have like really been like a challenge to you, by the society and the system around, right? So over the years, has that kind of improved, you feel, and what is it that you are doing currently at this point in time?
Well, I think philosophers and sociologists, there are people that call themselves transhumanists and so on. There are discussions, arguments. What will this mean? What will that mean? I'm more of a practical experimental engineer, so that's not really my field at all. But at least you can hear people talking about it. But then they're as you would be saying, they're talking the talk, but they're not walking the walk. They're not going further and doing experiments themselves. It's more philosophizing and speculating rather than, which is a shame. I'll take it further. I mean, we talked about sensory enhancement. I mean, the big part of the experiment that I did with the Braingate was with my wife being involved as well. She had electrodes implanted in her nervous system, and we linked our nervous systems together electrically. So it was very simple. So if she closed her hand, my brain received a pulse. So we did a very simple telegraphic communication from nervous system to nervous system, which to me, the next step is clearly brain to brain. So you're sending signals, not just telegraphic signals, dots and dashes and things like that, but all sorts of signals from brain to brain, which opens up the possibilities of communicating in a whole new way, which I would feel brain cells are ready for and so on. But I think even explaining that to some people, we're communicating in a simple way, nervous system to nervous system. What it will mean in the future is brain to brain. I think 20 odd years ago, it was too much for some people to even suggest you're doing something like that, never mind to write papers. And that for me was the big one, the possibility of communicating brain to brain. And I honestly, by now, I thought it would be a commercial reality. We wouldn't be communicating using this old-fashioned technology, pressure waves with speech and things like that, talking into a cell phone. I thought we would have moved on, so we'd all be communicating brain to brain by now. So the world hasn't moved on anything like as fast as I imagined it would. There's all sorts of ethical questions. Yes, I had ethical authority for the experiments that I did, but it was more of a medical ethical nature. The university essentially said, we're happy you're doing what you're doing as long as you get ethical approval from the hospital authorities. And the hospital authorities, the surgeons that were involved, helped that through because we were doing it more for therapeutic reasons than enhancement, I think, from the medical perspective. But I think it didn't question the big ethical issues. What about if somebody's communicating brain to brain? Does that mean they're sort of super thinking, or they're telepathic, or what will it mean to society? Those questions do need to be discussed, but I feel they can only be discussed with a background of experimental research going on to say this is what's realistic, this is what practically actually happens when you do that, not this other speculative experimentation.
We humans have continuously progressed and evolved over the years. Our communication, we have always communicated with language, but now if you look at the newer generation, I mean, the skills of, earlier you used to type, and then the typing skills have gone. You used to write. Now the writing skills are diminishing because, people have started using phones, and instead of typing with all your 10 fingers, now you've gone to just your thumbs. And, even the language, if you see, at least on the social media, while communicating the newer generation, when they wish people, whether it's happy birthday or things like that, it's HB to you, and that there's I see this decrease of using language. Possibly this communication via brain, could be the future, and I think we should explore those opportunities, because we sitting in this point of time where there's some really fascinating things happening in the space of technology. And if we leverage it for a common good and create technology which is human first, I think we'll be able to create a future which is really beneficial for everyone. Talking about enhancements, you spoke about in the same chip, even your wife had an implant, and how you could communicate over distances. What do you think that we can do at this point in time, 20 years later, and why is that not being done? I mean, could you talk about that?
So I think if we can link brains together, because we really are faced with a problem that we're using a serial interface. Either, if like now, I'm speaking into a microphone. Once it gets in the microphone, it's all electrical, and it can be sent different planets, to go anywhere, different people. But then when it gets to the other end, it has to be transmitted into some noise pressure waves, physical pressure waves again, serial signals to get into somebody's ears. I mean, ears and mouth were very good in many years ago when we didn't have anything, we could communicate. But now the most of the communication is done, I'll call it electrically, radio, whatever it is, in a different media, Whereas it's just that interface from the human brain to the technology, to the transmitter, from the receiver, and so on. And that's all. It's simple in a way. It's just, let's improve that interface. I am just experimented by plugging in from where the signals were, nervous system, or you can do it from the brain into the system, into the network, whatever. And then you're on, and as long as it's bidirectional, you've got both. There is so much to learn about that. What is the best interface? What is not so good? What will help us communicate or not? What is better for sensory input? Does it mean, as Elon Musk has been talking about, having lots of electrodes either on or in the brain? Maybe we need lots of electrodes. How big should the electrodes be? The electrodes I had were about 3 micrometers, so micro scale. You don't need to go to nanoscale. Micro scale is okay, but milli and things like that are far too big. So we need to experiment on the size that would be best if we're looking at communicating or sensing or motor skills. So there is so much research that needs to be done that can only be done through experimentation and simple trial and error. This didn't work so well, and research. And so we need a different basis for research, I think, because there's a lot of people happy to talk about it. There's a lot of people like Elon Musk, which is great, but we need more to speculate about this is what we're going to do. People seem to need to get on with doing it now and experimenting. So it's a challenge for researchers. Okay, it's going to be scary because we don't know what sort of world we're going into. there are going to be big positives. There might be some negatives, but that's the whole field of research. We need to experiment and get into it and find some results.
Right, fair enough. I think, whenever we create a technology, a tool, it always has pros and cons, and the only thing that we can do is keep on marching forward and making sure that the pros are more loaded than the cons. Maybe a couple of years back, there was a team who kind of, mapped out the entire cognitive structure of a C. elegans worm, and they put uploaded the same thing on a robot, and you did the same thing with a rat brain.
What we did, I mean, this is we could call cyborgs is a cybernetic organism where you mix biology and technology together. And what I've been talking about is a cyborg formed by plugging into a human nervous system or whatever. The other project I was involved with very much were taking brain cells from rat embryos and growing them, culturing them to form a small brain, if you like, and then putting that via a Bluetooth connection into a robot body. So the body was technology, a little as a robot as you would think of a robot, a little thing on wheels for the experimentation. It could have been on legs, but we use wheels, easier for it to stand up and so on. We didn't want that problem as well. And what we were getting it to do was to learn over a relatively short period of time how to move around in a small corral without bumping into the wall. So it had to learn not to bump into things. And I say learn in the sense that pathways through the brain had to strengthen and strengthen and strengthen over time, so that when it received a signal, an ultrasonic signal to say it's near the wall, it would change direction. So, and that's what it did. Because it's rat brain cells, they learn all the learning they're going to do over a relatively short period of time. So a couple of months, and it learned what was sufficient for the robot. It probably we're dealing with something like 150,000 brain cells. So it wasn't an enormous brain, but it was good for experimentation. And I think there are a number of groups working in a similar sort of area now. And it gives you enormous insight on what brain cells do, how they do it, how they change over time, how they can be excited and how they can strengthen in terms of communicating from input to output one way or another. I mean, it could, a lot more could have. It's different if it's a different type of robot. When the robot has a biological brain, it could be much bigger. I have to say, the main issue, technically, you can make it something like 60 million brain cells in 3 dimensions. Then you have little or no idea what's going on inside the brain, which is a problem if you're researching. And most of the brain cells are just hanging around, because if you give simple inputs to the brain, it's not really exciting the brain too much. And I think from a practical point of view, we found that after a few more months, if all the robot was doing was moving around in a little corral, it was bored. It was really bored to tears. The brain was not doing too much, and the connections were dying off and so on. I think it's something we need as humans. You've got to keep your brain active. You've got to keep doing things. Otherwise, the brain, it's going to die off. It's just going to, brain cells the connections will be lost. Brain cells will die. So you must keep your brain active. Certainly with our robots, we had nowhere near enough things. We needed a lot more inputs. We needed it to communicate, which we didn't have it communicating with other robots or in any other way. We were looking at fairly simple tasks, such as avoiding objects. Right. But it's a very exciting field. I mean, I have to say, it's incredible when you're actually, and should I be creating such a little creature like this. But from a research point of view, it's tremendously exciting when you see it improving and you see physically the neurons, the brain cells developing over time.
Some of the biggest companies are working to create artificial intelligence. And here we are. I mean, you're saying that, you could take a cell from an animal or any living being and culture it and then create a specific organoid, whether it's a brain organoid, and then you connect the same thing onto a robot, and it does the basic things. And you also pointed out that eventually, if the neurons, the brains are not doing enough, the cells starts dying out, and that's so very important for us living being also. We need to completely be a lifelong learner and keep on taking more information, learning. That's the only way we will keep on creating those firing and wirings to keep our brain healthier. Can you talk about your current research? What are you currently working on at this point in time?
Well, I have to say, I'll be honest, getting a little bit older now. I'm not as active as I was, but I'm still involved with looking at helping people with Parkinson's disease. This is deep brain stimulation. And the procedures at the moment, it is possible to use electrical signals to counteract the effects of Parkinson's disease. That's the muscle, when the muscles lock into position, or the tremors that you get. But what we're trying to do, the electrodes that go into the person's brain could be two sets of electrodes dependent on the problem they have, can apply signals into the brain, but we can also use them for monitoring the signals that are going on in the brain. And we're then feeding them into artificial intelligence systems, so the AI can learn a whole bunch of things. For example, what type of Parkinson's disease? We tend to think of Parkinson's disease as being one uniform problem. It's not. It's different for different people, and some people have different issues. Different, maybe they're more tremors. Maybe there's forgetfulness. There are different aspects to it. So the AI can learn, which helps the surgeon in treating them. It can wave a flag and say, hey, this person is more that way than, but also they can be treated in a much better way. But also it can predict, which is interesting, when the tremors, for example, are going to start. The AI system can predict, because it's getting information from deep in the brain, the subthalamic nucleus, the thalamus, right, tiny parts right in the center of the brain. It's getting information on what's going on, and from that it can predict, right, tremors are going to start in 10 seconds time. And the stimulating pulses only need to be applied when you've got the problem. They don't. So power packs are being used up much more than they need to be. Much more power is being, because stimulation is being applied in the traditional way of doing it all the time. It doesn't need to be. It can just be applied as and when it's needed. But this idea that you're looking at one part of the brain and waving a flag and saying, hey, this is what's going to happen, because the person doesn't know it's going to happen in a few seconds, whereas the AI system does. Other interesting things, of course, the AI system doesn't have to be on the person. The AI system can be in a completely different place. So you have the possibilities of signals being monitored in somebody's brain, but transmitted to somewhere completely different, where the AI system can then transmit signals back to them. So effectively, part of their brain is somewhere else, if you can understand what I'm saying there, practically, physically. But it's still part of their brain, which, again, this concept of networking, I think, improves the capabilities. So helping people with Parkinson's disease, it's a really rewarding thing that I'm involved with at the moment.
Lovely. Is there a way to do this non-invasively. I completely understand, these kind of problems, you have to like kind of reach the specific part of the brain. But is there a way you think, that we would be able to do this non-invasively?
I would have to say it's not easy to see that in the short term. The way the brain operates, signals normally this is the fourth square of our the signals disappear very, very quickly. Trying to pick up something that's going on in somebody's brain, even on you put it on the brain's surface, you're picking up information on maybe 20 million brain cells, which you've then got to try and make some sense of. With the sort of technology that I was using, the Braingate system, you can get signals on either individual brain cells or just from a very few brain cells. So you're looking at a very, very high resolution of information. And if you haven't got that, you're not getting the sort of information that you need, or you're not having that effect. I mean, that's one of the questions I would have with Elon Musk is, well, the type of electrodes you're talking about, are you going to have sufficient resolution? So it's a question, I guess. Are you going to have sufficient resolution to communicate and do the sort of things you want to do? I'm not sure. The things that I've done have involved something of a very high resolution that only comes through invasive signaling. But I would love to think that in years to come, somebody could analyze external signals and do the same thing. So I'm not saying it's not going to be possible, but at the moment, I think we're best to look at invasive techniques.
Which are the areas you think BCI is going to really, really help? You mentioned about deep brain stimulation of Parkinson disease, the entire brain-computer interface. I mean, whether it's invasive or non-invasive, which are the specific areas in the healthcare space you think?
I think any neural problem. So something like schizophrenia, which affects an awful lot of people in different ways, and we know very little about it. But the treatment of that, again, it needs experimentation. But that's what happened with Parkinson disease. It was pure experimentation that improved the situation. We learned from it how electrodes could be positioned, where they could be positioned, what sort of signals were needed, and so on. And so I think there are other neurological problems. I know with Tourette's syndrome, it's already helping. Epilepsy, again, and I think there's a lot of experimentation so we can learn more and more how it can help people with different neurological situations. But that's a lot broader than you think that it's opening up, because there's so many things where the brain takes over when perhaps you don't want it to. You want your brain to do something and it's doing something very different. For example, from an emotional point of view, our emotions we can regard as neurological signals. So how do we start affecting them? When you have a neurological problem that simple things that you can't get to sleep, or you can't go to the toilet, or because your brain is affecting you, maybe rather than taking chemicals to help you get to sleep, if we could just look at pressing a button and electrically you get to sleep, it helps you. Maybe it would be a lot better. Maybe it would be a lot less invasive in the chemical way. So I think looking at electronic medicine generally wouldn't be such a bad thing. It's a whole new business, a whole new scheme. And some of it, maybe we don't need to do a lot of invasive. Maybe it could be done externally as well. So big changes in the medical world should be coming about. We're on the cusp of electronic medicine.
2023, I mean, we still don't have a non-invasive BCI. I'm sure as a species, we've always augmented ourselves. I mean, it's always the initial stages is something, we say that, no, this is not cool, whether it was breast implant or something with the cochlear, this thing.
Things like glasses, external.
Exactly. Pacemakers and so on and so forth. We've always augmented ourselves, and implants will be a regular thing, possibly in another couple of decades. Like the glasses that you pointed out to us, the one which I'm wearing, possibly it's going to turn into AR, VR, MR glasses, which will make the entire world into a screen. And possibly through this only, maybe it could have some device which kind of reads up or cognitive structure and does the input, reading and writing of data, and connects to an external human being or a computer. And so, yes, I'm sure, I think that's the future. How do we get over there? I don't really know. And so you have also written books on artificial intelligence, and currently artificial intelligence is in its hype cycle, specifically because of the generative AI large language model ChatGPT-3. What are your views on artificial intelligence? And while you talk about that, you had actually also developed a genetic algorithm called Gershwin, which was about creating music. So maybe you could talk about that also.
Yeah, well, let's talk about Gershwin. I mean, it was just showing how simply you could. That was mixing music, essentially. And doing things that humans do. I think there used to be years ago a feeling, yes, well, AI can do things very quickly and very accurately, but it can't do things that you need creativity and imagination for. And I think Gershwin was just simply showing, well, no, you can write new musical scores and so on. AI is very good at doing that. You need some, because they're for human consumption, so you tend to need some feedback from a human to say, yeah, that's good or that's bad. But essentially, an AI can open up all sorts of possibilities there. AI can be far more creative than any human can be, because it can network, it can think in hundreds of dimensions, whereas the human brain is limited to 3D, and so on and so forth. Lots of advantages. So it's really showing AI can be extremely creative, much more creative than humans ever could hope to be. But AI can also be extremely dangerous. The book I wrote, way in '97, I think it was, March of the Machines, was looking at the potential for AI to take over, essentially. And it was looking at networked AI. And the whole basis was the I, the intelligence. If artificial intelligence can be, roughly speaking, as powerful as human intelligence, then it's going to be much, much better in many ways. It's still got those distinct advantages of speed and accuracy and network capabilities and multi-dimensional capabilities and so on and so forth. And we really do have to watch that it doesn't get out of hand. And I think this has been raised recently by several experts in the field. Well, it was in my book in '97 talking about exactly that, that potentially it's very dangerous. Unfortunately, I don't know that there's anything we can do to stop it, because we will push and push. That's how humans are, as you said earlier. The only thing I felt we could potentially do is to upgrade the human brain by linking with it, by plugging the human brain into AI ultimately, so it's not a human brain remote or separate from a machine network brain, but it's all in together, which means we're back to where we were. We need experiments in linking human brains together, I'm afraid.
Right. So could you maybe elaborate on this a little bit more? Because Elon Musk says the same thing. With the growth of artificial intelligence, the human machine merging, convergence is the only way out. I mean, could you talk a little bit more about that?
Yeah, well, Elon Musk, I would believe, is exactly right. I think the key thing is, if it is artificial intelligence, if it's just a computer program that is limited in what it does, I mean, you still might have problems with it, because if it's a piece of technology particularly in a military environment maybe or whatever, if it's getting in different sensory information, we may not understand that information anyway. We may assume that it's going to do something, but it does something else because the information it got was different to what we assumed it was going to get, because it's outside the limits of human understanding. Essentially, it's getting other information which affects it. But if it's AI and it's learning, I mean, that I see as a critical part of artificial intelligence, that the system learns, and if it's making a decision based on what it has learned, then it depends what it's learned as to what it's going to do under certain circumstances. Now, if we have limited, it's getting purely human inputs and purely human experience and so on, maybe you could say, well, it's not going to do anything we don't want it to do. But if it's getting any information that is not of a human background or human basis, we can't say that at all. We simply don't know. I can remember experimenting at a school with some little robots, and they were supposed to learn. This was with machine network type AI brain, not biological brain cells, but they're just supposed to learn how to move around in a corral and not bump into the wall. That was it, simple task. And the children in the school were crowding round it and stopping it. It could hardly move anywhere. And in the end, it appeared to have learned, it was still working, still operating, but it appeared to have learned, well, if I do anything, it's wrong, so I'm not going to do anything. So it had learned to stay still. Now we had never considered that that was a possible end result until it actually did it. And there it was fully functioning, but it decided, I'm not going to do anything because everything I do is wrong. Which you can imagine a human deciding to do something like that, but not a robot. It was beyond the parameters of what it had been programmed to do, because it had learned something based. That's a simple version of it. But I think from an external point of view, whether it's a financial system, a military machine, whatever, if it's an AI system and there are possibilities that it could learn a different behavior that you don't know about, then you've got problems. It could be potentially very dangerous.
Some of the top names in the world, including Bill Gates, Elon Musk, Stephen Hawking, spoke about AI being an existential threat, and the way we are going, where we just trying to create technology, because it's not just the institutions, even nations understand this very simple and clearly, that whoever has the access to the best technology is going to lead in the whatever you're doing, whether it's a nation or the world. Yes. So we in this capitalistic world, we are forever running towards acquiring that specific technology or a tool. And I hope that this tool doesn't get in the hand of a single organization or a single nation. I hope it's distributed. I hope that it's what it does is human first and it's benefit of the nation. Because yes, I mean, this for the first time in human history, I think we've created a tool which is self-learning. It can learn by itself. And though largely everything is programmed, it has also specific goals. And I'm sure to acquire its goals, it might not really look at human considerations, So I think we need to tread this path very, very carefully. Would you have any advice to young people who are interested in pursuing science and technology? And if yes, how can they make a positive impact on the world through their works?
Well, I would say, I mean, that there's so much of excitement going on now, particularly in the field of AI, in the field of implants that we've been talking about, helping people in the medical world. There's so much that can be done. There's so much we don't know at the moment. The field, we know everything there is to know. There's a load of rubbish. There's so much for us to learn, and it's so exciting. Whatever you do not become a businessman. Do not become a politician. What a way to live your life. Become a scientist, experiment. There's so much for us all to learn. It is such an exciting period at the moment. Please go for it. Grasp it in you and feel I'm going to achieve something different myself, because you can do it, because there's so much to be learned at the moment.
Right. Completely. Thank you, Kevin, for being part of the podcast. Yes, I think we live in a capitalistic world and everything is so top down and hierarchical. I mean, whether it's a politician, whether it's a businessman, I think we all run towards creating economical benefits and self-preserving and completely forget about the broader, I mean, the world that we live in. So I hope that, I mean, but I think the young kids are, even the young entrepreneurs are looking at businesses differently and asking deeper problems. So I hope that they solve these big problems. What comes next for you? And maybe paint a picture of the world is going to look like in the next 10 years.
I think, never mind the enhancement. I think the enhancement needs somebody to experiment. It seems somebody new, I think, to come along and try it. And hopefully more than one. I hope something of what Elon Musk is talking about actually comes to fruition in terms of some experimentation. He's been talking about it for a while now. I would love it if he experimented himself, but I can't imagine. But I do feel there will be some medical breakthroughs. I was talking about schizophrenia earlier. It affects so many people and affects the families of people around them. And there's not really medication. It doesn't work. There's not really anything that's really good for all people in that field. And I do believe electronically that there could be a major breakthrough, and I would love to see it. I'd be very happy for people to win the Nobel Prize by coming up with a treatment electronically for schizophrenia. That would really be pleasing, because I think that so many people would benefit from it, not just the people themselves, but other neurological problems.
Completely. I really hope so. I think EPFL is working on just maybe a couple of months made a paralyzed patient walk. There's other startups who are working on depression. I hope that comes into fruition. But really, really appreciate you taking time and being part of the podcast. And to my listeners, if you like what you see in here, then please press the subscribe button. And until next time, see you guys. Bye-bye. Thank you, Kevin. Really appreciate this.
Cheers, Eddie. Good talking to you.
Thanks a lot.